Nearly all tasks solved with machine learning involve three primary components: the machine learning model, the model training algorithm, and the model inference algorithm. These three parts are like the different stages of crafting a teapot from a lump of clay. First, you start with block of raw clay, which represent your machine learning model. At this stage, the clay can be modeled into many different forms and can be used to serve many different purposes. You decide to use this lump of clay to make a teapot. So, how do you create this teapot? You inspect and analyze the raw clay and think about what to change to make it look more like the teapot you have in mind. Much like the artist who gently make adjustment to make the clay look more and more like a teapot, the model training algorithm makes a small changes to the model parameters so we achieve our goals. Now you've made your teapot. It's been inspected, evaluated, and now it's ready for your enjoyment. You enjoy your teapot, drink your tea. This represents model inference. Now your model is ready to be used in real world. A model is a generic program made specific by data used to train it. Like a piece of clay, it can be modeled into many different forms and can serve many different purposes. A more technical definition would be that machine learning model is a block of code or framework that can be modified to solve different but related problems based on the data provided. In this example, we are using a linear regression model to predict the number of snow cones you might expect to sell based on the temperature. Our model here predicts that as the temperature increases, you will sell more snow cones. A model can also be used to predict how the number of people who attend college changes based on the cost of admissions. In this example, our model predicts that as the cost of tuition increases, the number of people attending college will decrease. But how does this model do this work? That is what model training is for. The procedure to use data to shape a model for some use cases is called model training. There are many model training algorithms. To understand how they work, let's go back to our flexible lump of clay analogy for a machine learning model. The first thing you would do is inspect and analyze the raw clay and think about how to change it to look more like the teapot you have in mind. Similarly, a model training algorithm uses the model to process data and then compares the results against a goal. In this step, we determine what changes need to be made to get to that goal. Now you shape the clay to make it look more like the teapot you have in mind. Similarly, a model training algorithm gently nudges specific parts in a direction that brings the model closer to achieving the goal. You keep doing these two steps repeatedly. Eventually, you get closer and closer to what you want until you determine that you're close enough to stop. Now you have your completed teapot. It's been inspected and evaluated. It's ready for your enjoyment. So, what does this mean from a machine learning perspective? We are ready to use the model inference algorithm to, for example, generate predictions using the trained model. This process is often referred to as model inference. We just described each of these steps in a bit more detail. So let's put it all together. First, you start with a raw piece of clay, which can be modeled into many different things. This represents a machine learning model. Next, you shape your raw piece of clay to make it look like the teapot that you always wanted. Similarly, the model training algorithm gently nudges parameters to make the model capable of solving the problem. Finally, you can enjoy your teapot and put it to work. This represents model inference. You use your model to solve the problem.